Welcome to my lesson of today. Our topic of discussion is acid, base, and salt. And we are discussing solubility and solubility curves. We wanted to see calculations. Visit my YouTube channel, James Marita, the Ocean of Chemistry, and then you can get more of these questions there. Our question of discussion today we have the solubility of a salt at 20 degrees is 25 grams per 100 grams of water. How much of the salt will it dissolve in 80 grams of water at 20 degrees to make a saturated solution? And before we do a calculation on this, there are some terms that you need to know. You need to know what is solubility, what is solubility curves, and of course what is salt. So let us have the definition of this salt, solubility and solubility curves first before we proceed. So when we are talking about a salt, salt is an ionic compound, so we can define it that a salt is an ionic compound. Salt is an ionic compound. Salt is an ionic compound. It's an ionic compound formed. It's an ionic compound formed when hydrogen ions nitrogen ions in an acid are partially or fully replaced by a metal. Replaced by a metal. Replaced by metal ion or ammonium ion or ammonium ion. So that's how you can define a salt. So a salt is an ionic compound formed when hydrogen ions in an acid are partially or fully replaced by a metal ion or ammonium ion. What about solubility? Solubility can be defined as the mass of a solute. So we have solubility is the mass of a solute, the mass of a solute, in grams, mass of a solute in grams that will dissolve in 100 grams of water, in 100 grams of water, 100 grams of water to form a saturated solution, a saturated solution at a given temperature. So that's how you can define a solubility, the mass of a solute in grams that will dissolve in 100 grams of water to form a saturated solution at a given temperature. What is now this saturated solution? The saturated solution is a solution that cannot, so this one is a solution that cannot, a solution that cannot hold any more solute, that cannot hold any more solute, any more solute, any more solute at a particular temperature, at a particular temperature. So these are the three some of the definitions that you need to know before you involve in the calculation of solubility. Let us now be back to our question. That we have the solubility of a salt at 20 degrees is 25 grams per 100 grams of water. How much of the salt will dissolve in 80 grams of water at 20 degrees to make a saturated solution? So we can say that 100 grams of water, 100 grams of water, 100 grams of water will produce 25. This one will produce 25 grams. So 80 grams of water, 80 grams of water will just produce 80 grams times, in this case, 25, and then you divide by 100. So you are dividing this one by 100. So if you can calculate that, so you have 80 in that case times 25, which is giving us 2000. Then we divide this one by 100, so this one is giving us 20 grams. So you can have this one as 20 grams. So the solubility of that one. So how much of the salt that you will dissolve in 80 grams of water at 20 degrees to make a saturated solution. So this one the mass of the salt that will dissolve to make that one is equals to be 20 grams. Question number 2. At 100 grams at 100 degrees, the solubility of a salt is 80 grams per 100 grams of water. At 20 degrees, its solubility is 42 grams per 100 grams of water. How much a salt will be deposited if a solution containing 500 grams of a saturated solution is cooled from 100 degrees to 20 degrees. First of all, we need to get the mass deposited. So first of all, get the mass deposited. So we have mass deposited, mass deposited, mass deposited, mass deposited equals to be it is 80 grams minus 42. So it's from 80 grams to 42. So we need to have the mass deposited here. So we can have 80 minus 42, and that one is giving us 38 grams. So the mass deposited is equals to P. We have this one as 38 grams. Therefore, we can say that 100 grams, 100 grams of 100 grams of water, 100 grams of water will dissolve 38 will dissolve 38 grams. What of now the 500 grams of water? So the 500 grams of water will just dissolve 38, in this case times 500, then you divide by 100. So that one will give us 38 times 500, get that, and you divide by 100. So this one is giving us 190 grams. So this one is 190 grams. So that is the mass of the salt that will be deposited if a solution containing 500 grams of a saturated solution is cooled from 100 to 20 degrees. The next question is the next question is uh, the mass of a solution of y. The mass of a solution of y. The mass of a solution of y. The mass of a solution of a solid y is 65 grams. This solution has 5 grams of a salt y dissolved in it. The solubility of the salt is 25 grams per 100 grams of water at 20 degrees. 60 grams of the salt was added to the solution at 20 degrees. How much of the salt remained undissolved? How much of the salt that remained undissolved? First of all, we need to have the 100 grams of water. 100 grams of solubility of that one is 100 grams of water at 20 degrees. It will produce 25 grams. So we have 100 grams of water will produce 25 grams. So we have 100 grams of water. At this one, the solubility we have, solubility is 100 grams per 100 grams of water at 20 degrees. So we have 100 grams, 100 grams of water, 100 grams of water will dissolve 25 grams of the salt. So we have 25 grams. So let us find the solubility at 65. The solubility, let us find the solubility at 60 grams. So we have 60 grams of this one. 60 grams was added at 20 degrees. So we have 60 grams at 20 degrees. So the solubility of this one, we can have 60 grams of water will dissolve how much? So 60 grams of water will dissolve 60 in this case times 25, and then you divide this one by 100. So we have the solubility at 65, the solubility when the 65 grams of the salt was added. So you have this one as 60 times 25, and then you divide this one by 100. So this one is giving us 15. So we can have this one as 15 grams. So this one is giving us 15. We have this one as 15 grams. Mass that remained. So we have salt is the mass of a solution of a salt water is 65 grams. So this is the mass of the salt. Then we have calculated the mass of the salt at 20 degrees when 60 grams of the salt that was added to the solution. So mass that remained undissolved. So you can calculate mass that remained, mass that remained, mass that remained undissolved, mass that remained undissolved is equals to, so we can have this one as 65 grams minus 15 grams. So we have 65 grams, 65 minus 15, and this one is giving us 50 grams. So we can give this one as 50 grams. So this is the mass of the mass this is the mass of the salt, that remained and dissolved. Visit my channel Marita James, then we have much of these questions there. Thank you.